Hey everyone, welcome back to my channel. Today we're diving into the fascinating world of algebra and exploring the expansion of algebraic equations. Now, firstly, what is an algebraic expression? An algebraic expression is a mathematical expression that contains variables, constants, and mathematical operations such as addition, subtraction, multiplication, and division. So, 5x plus 3. This is an example of an algebraic expression. 3x minus 7, 7x times 5, or even a fraction such as 9x over 3 are all examples of algebraic expressions. Now, what does it mean to expand an algebraic expression? The expansion of an algebraic equation or an expression essentially means simplifying and multiplying out the terms to get rid of the parentheses and combining of like terms. So if we have, for example, an expression such as 5x into 7 plus 3. Getting rid of these brackets or the parentheses would be us simplifying the expression. Single bracket expressions are the easiest ones to expand. For example, if we have 7 into x plus 4, what you essentially have to do is multiply 7 with x and multiply 7 by 4. So the resulting expression will be 7x plus 28, and this is as simple as it can get, so you've managed to expand it in just one step. If you have something like, say, 3 brackets x minus 5, it follows the same steps. You multiply 3 with x and then you multiply 3 with 5, so you get 3x minus 15. Now, double bracket expressions are trickier than single bracket expressions. Say we have x plus 2 and x plus 3 and they're multiplied. Now, to open these brackets, to solve these parentheses and to simplify them, expand this, what you need to do is first multiply x with both these terms and then multiply 2 with both of these terms in the next bracket. So this opens up into x plus 3 plus 2 into x plus 3. Now, x times x is x squared, and 3 times x is 3x. So x squared plus 3x, and then you move on to the next set of brackets, which is 2 times x will be 2x, and 2 times 3 is 6. Now that you've gotten this, you simplify it further by grouping like terms, in which in our case they're already grouped together, 3x and 2x, and you simplify them by just adding the coefficients. So x squared plus 5x plus 6, and this is as far as you can expand and simplify this. Now another example would be x plus 7 into 3x minus 11. Now it doesn't matter what numbers you have, or whether it's single powered x's or there's coefficient with x's, it'll always follow the same method, which is multiply the first term with both these terms and multiply the second number with both these terms. So this opens up into x times 3x minus 11 plus 7 into 3x minus 11. So this opens up to 3x squared minus 11x plus 21x minus 77. The like terms over here are already grouped, so just add them. 3x squared plus 21x minus 11x, just so it's easier for us, equals 3x squared. 21 minus 11 is 10, and it will be a positive, plus 10x minus 77. Now what if I had a bracket x plus 2 whole squared? Well, whole squared essentially means that the expression, the number, the term is being multiplied by itself, right? So I can write this as x plus 2 into x plus 2, and then I follow suit like I have with the previous two terms. So this opens up into x plus 2 plus 2 into x plus 2. So this becomes x squared plus 2x plus 2x plus 4, x squared plus 4x plus 4. And this is as far as you can expand this. And the same goes for if I had, say, 3x minus 5 whole squared. Being whole squared means that it's being multiplied by itself, so I can also write this as 3x minus 5 and 3x minus 5, of course, and then multiply this term with both of these and this term with both of these. So 3x into 3x minus 5 into 3x minus 5. So 3x times 3x is 9x squared. 3x times minus 5 is minus 15x. Minus 5 times 3x is also minus 15x. And minus 5 times minus 5 is positive 25. So here we have 9x squared minus 30x plus 25. Now there are some identities that can make life easier for us, that can help us in expanding certain type of brackets. For example, let's take the previous examples. Now the generalized identities are to open brackets which are whole squared. For example, a plus b whole squared. This can be expanded using the identity a squared plus 2ab plus b squared. And the a minus b whole squared brackets can be expanded using a squared minus 2ab plus b squared. And let's test if this works out. So x plus 2 whole squared, where x is a and 2 is b, this will be expanded by x squared plus 2 times x times 2 plus 2 whole squared, which is x squared plus 4x plus 4. The identity gives us the same expansion as when we multiply it. Now let's see if it's still true for the negative bracket. 3x minus 5 whole squared equals 3x squared minus 2 times 3x times 5 plus 5 whole squared. So 3x whole squared will be 9x squared minus 2 times 3 is 6 and 6 times 5 is 30 minus 30x plus 25. The expansion using the identities is the same as the expansion we did by multiplying the brackets. Now there's also a third identity, which is to multiply brackets such as which have the same terms but with different signs. So for example, if I had 3x plus 5 multiplied by 3x minus 5, how we normally do it would be the same way we've been doing this and this. So let's first do it that way, which is 3x into 3x and minus 5 and then plus 5 into 3x and minus 5. So this turns out to be 3x into 3x minus 5 plus 5 into 3x minus 5, which reduces to 3x into 3x is 9x squared, 3x into minus 5 is minus 15x, 5 into 3x is plus 15x, and 5 into minus 5 is minus 25. So 9x squared plus 15x and minus 15x just cancel each other out, so we're left with 0, and minus 25 stays minus 25. So from this, the general identity that we get is a plus b into a minus b equals a squared minus b squared, and this will always be true. So let's try it out with the question that we have done, with the example that we have done. 3x plus 5 into 3x minus 5, where 3x is a and 5 is b. 3x whole squared minus 5 whole squared equals 9x squared minus 25. And what do you know, it's the same as when we expanded it without the identity. So these three identities are pretty useful if you're expanding whole squares or brackets with the same terms and different signs. And I'll write them all once again. So a plus b whole squared is a squared plus 2ab plus b squared. A minus b whole squared is a squared minus 2ab plus b squared. And lastly, a plus b, a minus b is a squared minus b squared.